All right, today we have to remember to put our name, grade, subject, today's date, and then we are doing lesson 15, which is going to be equivalent fractions, which you guys know I'm excited about, and reducing fractions part 1. Okay, before we get into it, let's first remember, what do we mean by equivalent fractions? So equivalent fractions are different fractions that name the same number. Fractions that name the same number. Sorry, I'm squishing that in there. Okay? So if I had, for example, 1/2, which is the same as 2/4, which could be the same as 3/6, which could be the same as 6/12. They all represent 1/2. Okay? I put 1/3. I meant 1/2. There we go. Sorry about that. Okay. So that's what we're looking at for equivalent fractions. Now, I hope you guys are kind of like, oh, equivalent fractions, that like it's kind of like I reduced that and I got 1/2. I reduced that and I got 1/2, which we will get into. But let's first understand what they're referencing when they say equivalent fractions. So for example 1, it says find an equivalent fraction for 2/3 that has a denominator of 12. So in other words, what are we going to multiply 3 by to get 12? Answer on Edpuzzle. All right, you guys should have picked 4. All right, you guys should have picked 4. And remember, whatever we do to the bottom, we have to do to the top. So if I multiply 3 times 4 to get 12, I have to multiply 2 by 4, and we are going to get 8. Okay. So in other words, for equivalent fractions, we're kind of unreducing. I'm just going to put that. Okay. Now, for example 2, we need to find a fraction equivalent to 1/3 that has a denominator of 6. Next, find a fraction equivalent to 1/2 with a denominator of 6. Then add the 2 fractions you found. All right, this sounds like super extra, but we did this a lot last year. But let's just, it's a good review. Okay, so I have 1/3, 1/2. I need it to have a denominator of 6. And this one also denominator of 6. So I'm going to start off with the 1/3. What am I going to multiply 3 by to get 6? I'm going to multiply this by 2, but remember it's going to be 2/2. And then what am I going to multiply 1/2 by? I'm going to multiply 1/2 by 3/3, so my denominator is going to be 6. So it's 2/2 and 3/3. So 1 times 2 is 2, 1 times 3 is 3, and then I'm going to add. And remember, I'm going to add my numerator, denominator stays the same. So I get 2 plus 3 is 5, and then 6. Okay? All right, so that's it for the equivalent fractions. Now we're going to start looking at the reducing. Remember, when we go to reduce fractions, we need to identify what the lowest factor is. Yes. So let's write that. Reducing need lowest factor. Remember, factor is the numbers that we use to multiply. The reason for that is because we're going to, oh wait, sorry, not lowest factor. I want the greatest common factor. Ooh. I was trying to go from here to this. Okay. Okay, sorry, we need... All right, our next topic is going to be reducing. For reducing, we're going to need the greatest factor. The reason why we're going to need the greatest factor is because it will make it easiest to reduce. So kind of like my example here, I could have done 6 over 12, reduced it by 2, and then I would have gotten, let's do that. So I'm going to reduce by 2, so I would have gotten 3 over 6, which I then could have reduced again, then by 3 and gotten 1/2. So I had to do it in 2 steps. If I knew my greatest common factor was 6, I could have just divided both parts, top and bottom, by 6 and gotten 1/2. Okay? So we're just trying to do this in the least amount of steps. So for example 3, we have 18 over 24. 18 over 24. What is going to be our greatest common factor? Answer on Edpuzzle. All right, you guys should have gotten 6. 6 is going to be our greatest common factor. So 18 divided by 6 is going to be 3, and 24 divided by 6 is going to be 4. So for example 3, it would have been 3/4. Now we have example 4. Example 4 wants us to reduce 3 and 8/12. Now remember, when we go to reduce a whole number, when we're going to reduce a mixed fraction, we don't touch the whole number. The whole number stays the same. So what is our GCF for 8 and 12? It is going to be 4. So I gave you guys the GCF. Tell me what the answer is on Edpuzzle. All right, you guys should have gotten 3 and 2/3. Because we divide 8, 8's divided by 4, we get 2, 12's divided by 4, we get 3. Okay, this lesson has a lot of examples. Example 5. Okay, example 5 wants us to write 12 over 9 as a mixed number with the fraction reduced. So it's 12 over 9. I'm writing this in the wrong color, it's okay. Now remember, what we have to do is we need to divide. 9 goes into 12 how many times? The remainder becomes our new numerator, our denominator stays the same, and then we will reduce. Do this one on Edpuzzle. All right, you guys should have gotten 1 and 1/3. Now you could have also reduced it by 3 over 3 and gotten 4 over 3 and then gotten 1 and 1/3, or you could have simplified it, in other words, made it into a mixed number and then reduced it. That would have been okay too. All right, and now we have example 6. Example 6 wants us to subtract and then simplify. Remember, when we go to subtract, the denominators need to be the same. And do this one also on Edpuzzle. Okay, you guys should have gotten, in the end, 2/3, because we subtract 7 minus 1 is 6. 9 stays the same until we have to reduce. We can reduce top and bottom by 3. All right, we're on the last 2 examples, guys. Last 2. Example 7. Example 7 says, write 70% as a reduced fraction. So 70% reduced fraction. Remember, a percent is always over 100, so I'm going to do 70 over 100. Answer this one, also an Ed puzzle. All right, for this one, you guys should have gotten 7 over 10 because we can reduce both by 10 over 10. Now, the other way, the trick way, is because the numbers or number in the ones place value for both is 0, we could have just crossed that off. And notice we still get 7 over 10. That one's always a nice one when you have the factors of 10 there. All right, last but not least, example 8 brings back an old dear friend probability. It says, with one spin, what is the probability that the spinner will stop on 4? Now this spinner is unlike any other spinner we have looked at. It is broken up into eighths. 1, 2, 3, 4. 1, 2, 3, 4. So in other words, we want to know what's the probability of it landing on 4. Well, how many 4s are there? 2. How many parts, possible outcomes? 8. Can we reduce this? Yes. By what number? 2. 2 goes into 2 once, 2 goes into 8 4 times. So our probability of it landing on 4 is 1/4. All right, I want you guys to do these 3 mastery check questions. Good luck.